So this is the 5-1 notes. We're going to talk about mid-segments of triangles. So the triangle mid-segment theorem says if you have a segment that has the midpoints for 2 of your sides in your triangle, then you can say that that segment is parallel to the 3rd side. So let's see what that looks like. So go ahead and draw this triangle on your notes. So if we have triangle ABC, if we have triangle ABC and the mid-segment So we have A, B, C, and then D is halfway between A and B, and E is halfway between B and C. When you're midpoint, you create 2 congruent halves. So these 2 segments are congruent, and then E is halfway between B and C, so it creates 2 congruent. And they don't have to be congruent to each other. But they will be, if it's midpoint, it will be congruent to its other half. And then you can say, if this is the case, then you can say that this mid-segment is parallel to your base. Now, I'm really amazing at algebra. That's where I excel. That's my favorite subject in math. So anytime I can get my hands on a formula, I'm all over it. So this second part, the 3rd side is half as long. I've made you guys 2 formulas you can use to help you with this relationship. The first one is when side AC is equal to twice the length of DE. So I like this theorem because it is exactly as it looks. This segment is twice the length of DE. So make sure you guys write this formula down because it is not anywhere in these notes. If you don't write it down, you will not have it. It'll be sad and you'll be crying. I'm like, don't cry. It's a formula. Watch the video. You can get it. The second way we can write this same information is that DE is half of AC. So DE is equal to 1/2 times AC. You can use this either way, depending upon what you have and what you need. One is more advantageous than the other. If you just want to use and memorize one will get you everything you need. You just might have to solve. Okay, let's look at example 1 together. We're going to graph a triangle. Yay, graphing. With vertices A at 4, 6, B at 6, 0, and C at 0, 0. We're going to find the midpoints of AC and BC, label them D and E. Then we're going to show that DE is half the length of AB. Okay, so we got 2 things going on that we thought we could ignore and get rid of forever, but they keep coming back to haunt us. Thank you, virus. They're like the virus. They stay in our system forever. The good news is, you need to stand up and get a clipboard. Go ahead and do that, okay? Okay. The good news is that when you get a virus, your body makes an antibody, and you have those antibodies forever, and your body will fight the virus. Yay! The bad news is sometimes you have flare-ups. So let's graph these points. A is 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. When I graph, especially when I'm using distance formula and midpoint formula, I go ahead and not only put the letter, but its coordinate that goes with it. B is 6, 0, 1, 2, 3, 4, 5, 6. And C is 0, 0. Oh, thank goodness. I love things on the origin. Okay, so what I did wrong the first time I gave this lesson is I didn't use a straight line. So we're going to draw as straight a line as we can from A to C, from C to B, and from A to B. Straight a line as you can. Because we are going to try to find the midpoints, and if we mess that up, the midpoints, then our line is wonky and our midpoint doesn't fall. So the more accurately we can graph this, the more advantageous it is for us in solving this problem. Okay, so we're going to find the midpoints of A and C. Let's do that first. So A is 4, 6, and C is 0, 0. Midpoint formula. Now, because I drew such an amazing graph, I can tell where the midpoint is going to be. But because I am mistrustful of my own abilities, I'm just going to do a double check here using the midpoint formula, and it gives us practice using the midpoint formula. So we're going to go x1 plus x2 divided by 2. So here's the x's. I'm just going to add these together, divide by 2. Here are my y's, 6 plus 0 divided by 2. Some of you guys really struggled with this on our last test, so I want to make sure you guys know how to use the midpoint formula. 4 plus 0 is 4, divided by 2 is 2. And 6 plus 0 is 6, divided by 2 is 3. And so our midpoint is at 2, 3. Over 2, up 3. Oh yeah, it's right here. We're going to label it D for delicious. All right, so let's do the same thing with BC. Nope, not delicious. So to find BC, B is at 6, 0. C is at 0, 0. So the midpoint is going to be 6 plus 0 divided by 2 and 0 plus 0 divided by 2. Now, some of you guys may be sophisticated enough to sophisticated is very fancy. You guys may be sophisticated enough to know the top of our dirt. The halfway between that is at 3, 0. But once again, I'm showing you the midpoint formula so that when you encounter it on your own, you feel confident and comfortable. You're like, yeah, Miss Alvarez, this is like 10 times and we didn't even need it. So the 6 plus 0 is 6, divided by 2 is 3. 0 plus 0 is 0, divided by 2 is 0. And our midpoint is at 3, 0. And we're going to name that E4. Easy. E for easy, because this is mega easy, right? Finding the midpoint. Okay. Show that DE, oh, this sounds like a distance formula issue. So let's draw a line for DE. So I'm going back and reading the instructions. And some of you guys were really struggling with instructions on the last test. It says right here, show that DE is half the length of AB. So let me highlight what we're looking at. Sometimes just having that highlighted. So DE is right here. AB is right here. So we're going to find the distances of those two lines using our good friend the distance formula. Then we're going to show that DE is half the length of AB. All right. So let's go ahead and grab our distance point. Oh, that is not what I wanted. I wanted to grab it, and it erased it. Oh, this is a major fail. Okay. I'm just going to go ahead and rewrite that distance formula. to your head. So x2 minus x1 squared. Notice the pattern with these formulas. The distance formula is the difference of the x's. So the x's go together, and then the y's go together. Some of you guys shuffled that around on your performance task, and it was really sad to not be able to give you credit. Okay, so we're going to find the distance between DE. So delicious and easy. So I'm going to say that D is my x1, y1, and E is my x2, y2. If you want to switch it and have E be x1, y1, it doesn't matter. The end result's going to be the same. So we're going to take our x's and subtract them. Then we're going to square that result. Then we're going to take our y's and subtract them. And we're going to square that result. If you cannot remember the distance formula, you can go ahead and use Pythagorean theorem, because it's just this little right triangle here. So it's going to be 1 squared and 3 squared. Sorry. Huh? Oh yeah, I was going to say that because that's, thank you. This is 2. I was like, it's not matching the picture. Because this one should be 1 and this one should be 3. So I should get 1 squared and negative 3 squared, or 1 and 9. So DE is the square root of 10. I'm not going to go any further with it because 10 cannot be simplified, and I do not want to write down the decimals. Okay, we're going to show the instructions say, show that it's half the length of AB. So A is 4, 6, and B is 6, 0. So we're going to distance formula so we can find the distance between A and B. And if I look at the picture, the little right triangle that goes with it should be 2 squared and 1, 2, 3, 4, 5, 6. 6 squared. So even if your numbers go completely sideways, you can look at the picture to help you keep on track with what you should be doing. So when I subtract my x's, I should get 2. And when I subtract my y's, I should get 6. So let's go ahead and do the math on that. So here's my x1, y1, x2, y2. 6 minus 4 and 0 minus 6. 6 minus 4 is 2. And that gets squared. And then 0 minus 6 is negative 6, and that gets squared. This gives us 4 plus 36, which is square root of 40. Is the square root of 40 twice as much as the square root of 10? It's a little bit difficult to see. So what we're going to do is we're going to simplify the radical for root 40. What perfect square is a factor of 40? Perfect square. I'll give you a hint, not 8 and 5. 4. So 40 is 4 times 10. And those of you guys who are struggling with that simplifying radicals on your review worksheet, pay attention right here. This is like a lesson in a lesson. So the square root of 4, I know it's a perfect square, so he gets busted out of the square root prison and gets to be a 2 on the outside. On the outside, he's 2. And then poor 10, not a perfect square, gets stuck in the middle. Still in square root prison. Okay, so now can we see that DE, DE is half the length of AB equals 1/2 AB. So let's do a little check. So DE was root 10 and AB was 2 root 10. I have 2 root 10s. What is half of that? 1 root 10. So we can say root 10 is equal to root 10, and we have shown that DE is equal to 1/2 AB. So what are 3 pairs of parallel segments in triangle DEF? One way that you can help yourself answer the question correctly, if they're asking for 3 items, put a 1, 2, and 3 down so you can remind yourself that you're looking for 3 things. Sometimes you get so caught up in a problem, you do 2 but not the 3rd. And then it's really sad for me when I grade it. I'm like, oh, what's that 3rd one? So we're going to use the Midsegment theorem to identify the 3 segments. I'm going to use my highlighter. Okay, so when we look, let's look at DF. To say that 2 lines are parallel within a triangle, we need to make sure that the line in the middle of your triangle is actually a midpoint of each side. So when I look at point R, to the left and to the right, I have a congruent statement. So I can say R is definitely check a midpoint. Then I'm checking that S is a midpoint. We look at the congruent statement. I got a congruent and a congruent, so S is definitely a midpoint. So in order to use the theorem, do not just use it willy-nilly. Double check that you have the congruent side so that you're truly a midsegment. So we're going to say, that's not what I want to say, that RS is parallel to DF. Now you guys are lucky. You can go ahead and rotate your paper clockwise. So now we're going to look at base EF. I have to just go like this and tilt my head to the side because my smartboard does not rotate. And we're just going to double check. We've already double checked R. Now we're going to double check T. We do have a congruence marking to the left and to the right of T, so we can confidently say that T is a midpoint. So we can say that RT is parallel to EF. And then let's rotate our paper around again so that DE is on the bottom. So we're looking at DE like it's our base. And then which midpoint line matches up with DE? ST. So we got ED and ST. Okay. That was it. That was it for that one. Not hard, right? So you guys are going to be asked to find, so this gets a little bit more difficult, but thankfully you're on paper so you can shift it around. So in triangle QRS, T, U, and B are midpoints. We got the little tub. What are the lengths of TU? Go ahead and highlight it. Okay. I'm going to give you my highlighter. That's fine. TU, UB, and QR. So the first thing we're going to do is find the line that's parallel to TU. this. So TU is parallel to SR. And in fact, TU is equal to 1/2 SR because of the mid-segment theorem. Now I'm glad I have a formula. So TU is equal to 1/2. SR is 40. So it's equal to 20. All right, that answers our first one. So check. UB is next. The line that is parallel to UB is QS. And UB is equal to 1/2 of QS. So UB is equal to 1/2 of 50. Thankfully, I grew up where, back in my day, quarters had real money value. Quarter meant something, and I actually paid for things with quarters in the old-timey days. So UB is 25. And then the last one, QR. QR is twice the length of TB, because QR is the big guy. The big guy is 2 times the little guy, or the little guy is 1/2 of the big guy. So in this scenario, I'm going to use the other formula. So QR is 2 times 30, which, what? Is 60. Totally easy, right? Muy fácil. All right, we have a sinkhole. A geologist wants to know what the distance AB across the sinkhole is. Choosing a point E outside the sinkhole, she finds the distances AE and BE. And she locates the midpoints C and D of AE and BE, and then measures the distance between those midpoints. What is the distance across the sinkhole? Please tell me you guys can do this super muy fácil, right? What is it?
92.
92. So it's twice our midpoint, or 92 feet. Make sure, especially on performance tasks, do not skip that step at the 2 times 46 so that the number just doesn't appear magically out of thin air. I needed so much paint for that, actually. Okay, so I want to just give you a little talk about 41 from your homework assignment. So I haven't given you the answers, but I've given you the setup for this. So if we have this initial triangle, and we use AC is equal to 2 times DE, so our short guys, our long edge is twice the shorter side, I can say that twice the short side is equal to this long side. That's this one right here. Twice the short side is equal to the long side. Once you get that, you can solve for x. Once you have x, you can put it into the second equation that you're going to get. Twice the short side equals the long side. So 2 times y equals 2x plus 1. You will have found what x is. You're going to plug it in here, and then you can solve for y. Okay, and then I want to talk you through this little proof right here. So we're going to try not to make it as complicated as it emotionally wants to be, but we're not going to do that. We are given that ST and U are midpoints. Our fourth triangle, so we've got this triangle here, YST, congruent to TUZ, congruent to SDU. And then this middle triangle here, TUS, is also the missing congruence triangle. So we're going to use the midsegment theorem to identify all the parts that are related. Once we have all the related sides, then we can say that our triangles, these four triangles, are congruent by side, side, side. So don't make it more complicated than that.